So till yesterday we were doing with uh, all the switching protocols. We started with switching protocols yesterday, right?
Yes.
You remember? Do you remember them? DTP, dynamic trunking protocol, VDP, VLAN trunking protocol. What are the VLANs and why do we use trunk?
Yes.
Okay, so we have also seen CDP, LLDP, which is open standard, right? So now spanning tree protocol. Okay, spanning tree protocol. What is spanning tree protocol and why networking has come up with this protocol in layer 2? Okay, I'll tell you in layer 3, that is in the network layer, when the data is flowing in between the routers. Okay, in between the routers or among the routers. Okay, if there is any loop like this, right? If there is any loop like this, for some, I told you, uh, for somehow some misconfiguration did, and a loop has occurred, and once a packet has come here for something, it will be revolving in this itself, it will not be going out. In order to avoid these, at layer 3 we have TTL value, we have concept of TTL, right? Time to live. We have this concept time to live at layer 3. Why? To avoid loops. Somehow if they occurred at after some point of time, it will be gone. But at layer 2, in the layer 2 header, in the Ethernet header, okay, in the Ethernet header, we don't have any such field which says that this frame has to be edged out after this time. We don't have such type of field such as TTL in layer 2, that is in the Ethernet header, right? We don't have any such field. So what happens because of some misconfiguration, maybe, right? Because of some misconfiguration, maybe, or somehow think that there occurred a loop between two switches. You're getting my concept. If there occurred a loop in the layer 2, how to avoid it? How to avoid it? In order to avoid that, we use this protocol.
Right.
Mhm. Right. So how do we avoid it? First I'll tell you. Okay. First I'll tell you how the loop, how there will be scope of loop, and later on then we'll discuss the span protocol. Okay. This is my PC. Right. This is my PC. Or suppose he is Mac. His MAC address is A. Right. I have my switch 1, and this is intern connected switch 2, and this will be connected to my PC P. Got it? I used here two links for redundancy. Okay, both will be working, but somehow if one goes down, other will be responding, other will be on the duty. Okay, now switch A, switch A, see, PCA, PCA. wanted to communicate with PCB, wanted to communicate with PCB. We generated ping, but there is no MAC address of the PCB. So what will it do? What will it generate in order to find the MAC address? ARP request, right? ARP request. It is either the unicast or broadcast. Broadcast. So it generated an ARP request. Okay, it generated an ARP request. Forwarded. Switch will learn MAC address based on will switch will have one MAC address and MAC address table, and it will learn the MAC address. Switch will learn the MAC address.
Yes.
How?
It will broadcast it. It will broadcast it.
So switch receives the frame. It will check the what is this
Trust not that.
in the frame, and it will learn the MAC address, right? So it will learn, for suppose saying that this is my port number 1, this is my port number 2, this is my port number 3, and this will be my port number 8, this will be my port number 9, and this will be my port number 7. Okay, now he received the frame. He will learn the MAC address of A on port number 1, right? So switch 1, switch 2, right? Port number 1, port number 2, port number 3, and port number 7, port number 8, port number 9, right? Now it learn MAC address on port number 1. What is the MAC address? A, right? A. And what it has seen, it how does it switch the packet based on destination MAC address of the frame,
Yeah.
right?
But it is not.
Yes. So it will check the destination MAC address. It is broadcast. So it will ultimately forward the packet through all the ports. So it has forwarded it through this port, and it has also forwarded it through this port, right? For timing thing, that switch 2 has received the frame on port number 8. Okay, on port number 8, now it learned again, it received the frame, so it will learn the MAC address, of course, using source MAC address. On port number 8, it learned MAC address. What is the MAC address? A, source MAC address. And again it has to forward the packet. It will check the destination MAC address. What is the destination MAC address?
But it is
Broadcast. All the F's.
not. Yeah.
All the F's. So it will broadcast it. So what will happen? It received the packet. Okay. Now switch B is forwarding the packet on this port and on this port. Switch will never send the packet reverse back on the same port on which it received. Okay. So it didn't send the packet here, but it forwarded the packet out through this interface and this interface. Okay. Now switch 1 again learned the same MAC address. Again it got the same packet. It learned the MAC address on 3 as A. Okay.
Yeah.
So now what it will do is it received the frame on port number 3. It got the packet. It got the frame on port number 3, right?
It's not packet that we are sending.
Yes. So now what will happen? Switch will wipe out this MAC address A on port number 1, and it will learn MAC address A on port number 3. Ultimately, again, it will see what is my destination. To whom should I forward? It is again broadcast. Same packet broadcast. It will forward it out through this interface, and again out through this interface. Right. Now again this switch learned A here. It forwarded back. Right. Now this packet ARP request will never have an end. Why? Because It is keep on revolving in between these two links. It will never have end. For time being, meanwhile, for suppose meanwhile think that A has sent another frame. Till now it was having MAC address A on port number 3. Now again it received a frame on port number 1 with MAC address A, source MAC address, right? So what will it do? It will wipe this here and it will write A and it will forward it. Again this frame went out, this frame looping frame went out and again came back on the same interface, ARP request. Okay, ARP request. These red ones think that the red ones are ARP requests and this hash one is a this frame. See, this color is some other data packet. Okay, now the ARP request again came out here and came in again through this interface. Okay, by again it came here, came back here. It will learn again here. It will wipe out here and it will write the same thing. So what happening is, what my concern is, same MAC address, it is learning on 2 ports. Okay, it is learning on 2 ports. Okay, one after the other, one after the other, one after the other. Actually, switch will, if once, okay, switch will never learn single MAC address on 2 ports. Okay, if it has received frame on port number 1, it will learn it. And for supposing that it got the same frame on port number 2, it will wipe out the same MAC address A from this port and it will learn from this port, right? So what's happening here? MAC flapping. We call it as MAC flapping because for some time being it is learning MAC address A on port number 1 and after some time it is learning the same MAC address on port number 3.
Yes.
And again it has to wipe this out and it is learning on MAC address on port number 1 and after some time again it is wiping it out and again it is learning here. This process we call it as MAC flapping. Okay, if in real time scenario if this is happening, the switch will notify you that MAC flapping is happening. Then it will notify that go and check your configuration, there might be some misconfiguration. It will notify you. So here there is no end for this loop. This packet will never die, right? So if this packet is generated and if the loop has occurred in real time scenario, a switch, if this loop has occurred within 20 to 30 seconds, within 20 to 30 seconds the switch will go down. Okay, yes, it's not like particular time, but the traffic the switch experiences is that much. I told you with this in detail. Okay, I told you this in detail actually what happens. Okay, but all this process happens around some thousands of times, some hundreds of thousands of times within 1 second on the switch. This whole process. Okay, but within 1 second, some thousands of times, some hundreds of thousands of times the switch has processed the same packet. You're getting my concern?
Yeah.
Same packet is being processed some hundreds of thousands of times within 1 second. So the CPU utilization will go up and the switch will come down. It has to be restarted again. Okay. So in order to avoid these loops, we use spanning tree protocol. Okay, we use spanning tree protocol.